pulling a sheet east with a force of 2,000 Newton.
Okay, so when we draw that one, that's to the right, it's 2,000. And then the next part?
Another campus is pulling the same sheet northeast with a force of 2,000.
The same 2,000 then. Okay, so we have east and northeast. So before we even work it out, if we just think about east and northeast, which way should our answer point? Just like roughly. Should be somewhere in the middle, yeah. So if we were to calculate the angle, what type of angle should we get? Somewhere around about half of 45. So something that's about 20 degrees would probably tell me I did it right. Okay, so the first factor here is 2,000 newtons. And the second vector here is also 2,000 newtons. What I'll do is I'll resolve the second one into this direction and this direction. And we know that this is 45 degrees. And you learned that because this one touches the angle, it will be 2,000 cos 45, which is 1 over root 2. And this one will be 2,000 sine 45, which is 1 over root 2. So in the picture, what I have now going up, I have one vector going north, but going east I have two vectors. The 2,000 times 1 over root 2 plus the other 2,000. Yeah? Sorry, that's a multiply. 2,000 1 over root 2. Okay, so let's see, what is this top one here? 14, 144, 414, 14. Point.
14.
Oh, just like this. Okay. And then this one would be 3,414 newtons. So I need to go back now. How do we get the magnitude? What do we use to get the magnitude? Do you remember? Yeah, what's it called? Correct. So this will be square root of 1414 squared plus 3414 squared. What's that, please? 3695 newtons. And this angle here, alpha, is tan inverse 1414 over 3414, which 22.5. So the answer is 3695 newtons in a direction east 22.5 degrees north. Yeah. How's that one now? Are we okay with that?
Yeah.
Yeah. What's the next one? Is it 7? Yeah. This is the block and the wedge, isn't it? Yeah. Okay. Give me the info. Oh wait, sorry. Does anyone need to write that down?
Yeah.
Yeah. Okay. Just let me know when you're ready.
Okay.
Yeah, good. Okay. Right, so the next one now. Everyone over here okay with the job? Alright, so Monica, give me the info here for this. What's happening?
A block M2 lies down a 45 degree wedge M1 at a constant speed of 2 meters per second.
Okay, so let me just draw what we have so far. So this is going down with 2 meters per second, yeah?
The
And
wedge is 45 feet.
okay,
And the wedge is moving away at a constant speed of 3 meters per second.
okay.
By resolving and adding vectors of the final net magnitude, the direction of block M2 velocity.
Okay, great. So, block here, it's not really moving at 2. I mean, it's moving at 2 on the face here, but the face, the wedge, is moving. So these two have to combine. So the final result will not actually be a 2 in this sort of south-west direction. The effect of the tree will probably reduce this 2 because they're roughly in opposite directions. So let's see what we get. I'm looking for the block here, isn't it? So what I'll do, I'll just draw the tree here instead of here, just to put them together. And really, all I'm doing is adding these two vectors together. That's maybe easier said than done because we could make triangles, but if we want to be accurate, we should resolve one of the vectors. So the question then is which one to resolve. Should I try and resolve the tree or resolve the 2? Well, the tree is okay because it's already horizontal. It's the 2 that we need to resolve, this way and this way. If that's 45, then this is 45 from that geometry fact in maths that this angle is the same as this angle. Did you all learn this one in middle school?
Yeah.
Yeah?
Yeah.
You look so confused, Monica. That's the correct word? Isha? What was I saying? Oh yeah, so that's 45. So this is 2 cos 45. And this is 2 sine 45. So, what is 2 cos 45? Is that bigger or smaller than 3? It's got to be smaller than 3, isn't it?
Yeah.
Yeah. So what will happen is you'll be left with, to the right, 3 minus 2 over root 2. But you still have a downward 2 over root 2. So, what are we left with here, please, as a decimal? And here, please. What's this number on the calculator, yeah?
1.586.
Thank you. And this one?
1.416.
414. Okay, so this, although we think it's heading down and left, because the wedge is moving, it actually will head this way, because the wedge is moving quite fast to the right compared to the block. So let's get the magnitude. I'll just call this or. The magnitude of or is square root 1.586 squared plus 1.414 squared. What do we get here? 2.12, is it? Thank you. And I'll get this angle, which will be tan inverse 1.414 over 1.586. Yeah. What's that angle then? 41.71 then. Okay. So the answer is it will move at 2.12 meters per second at an angle downwards of 41.7 degrees to the right. Okay, so yeah, that one's a bit tricky, but now that you've seen it, I hope it's okay. Any questions on these two examples? They're okay?
How do you find the angle?
Yeah, if I think about this as a triangle, so if I draw this side here and make a little triangle, this is 1.586, this is 1.414, and if I look at this angle, and then if I do this, I can do this. I'm sure I can do this. Hang on, how did I do this? All right. Yeah, there we go. Dun, 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 dun. There you go. So now if we look at our triangle, this angle here, alpha, we can say tan alpha is the opposite over the adjacent. 1.414 over 1.586.
Yeah, but that side doesn't necessarily to be 1.414, right? Because if the angle different and the length different.
This side
Yeah.
is not 1.414. Tell me why not.
Because if so the angle is tan, so you go steeper, not steeper, further, so it will be shorter, right?
Huh? Simplify this to me. I'm quite tired. What are you saying?
It's the angle, the steeper the angle, the longer the length over here. So it's if not, it will be shorter. Right, the angle affects the length.
True, but I'm not sure what your problem is. You know, you're not happy that it's this number?
Yeah.
Why not?
How we get that? I mean, it doesn't necessarily to be same to the opposite.
I thought this number was this number. Oh, I see what you mean. Okay. Here's my vector. Here's my vector.
Yeah.
This is 90. So what I do is I draw this vector here. So I just transfer it. So I slide this vector to the right so that I can make a triangle. This triangle here, I deliberately draw this to be the same as this vector. Yeah. It's let me show you here. If you have this and this and this and you want this angle, I need to make a triangle. So I make my triangle here so that this side is the same as this side. Yeah? Is it okay? Are you cool? Are you sure?
Yeah.
Okay. I'll have to trust you on that. Right. What else now? Yes, another page. Okay. Is that the last one? Is that the cyclist on the truck or something? Yeah. I'll just wait a second for these people to write it down and then I'll do it. Yes.
How can I find this question more about me? Why? Is there a website?
More examples. I have more examples I can give you, but I wouldn't panic so much about this one because this would not really be a typical exam question. It'd be quite a hard question. So I can give you more, but I wouldn't really be stressing about this. It'd be more like question 6 that would be an exam type of question. But if you want, I can give you more, but I'm worried that by giving you more, I'll be making your life more difficult than it needs to be. But I think if you Google something like block and wedge questions, you might find stuff, but you'll find that they will be quite hard and harder than this. Right, what's the... Oh yeah, so the... Sorry, I can go on to the next one now? Yeah? Okay. Who was looking for that? You were, or you were? Number 5. Time velocity. Velocity time graph. Okay, I'll let Jerry read this to me now. Go for it, Jerry.
Is that equation of motion?
Correct? No, it's velocity time graphs.
I want the more.
Huh?
I don't know.
You don't want to read it?
I don't have a question about it.
Oh, okay, fine. Okay, it looks like... Okay, wait, pause. I need to draw as you talk. Okay, so we have a cyclist and lorry.
Yeah.
Okay, continue.
The cyclist can accelerate
Yeah.
and a rate of 5 as negative now.
Close enough. Continue.
And has a top speed of 10
Yeah. So Jerry, if you see this, you can say meters per second, or you can say ms to the -1, or you could even just say ms -1. But most people say meters per second. And this one?
meters per second.
Correct. Okay. Continue. Oh yes. And before I continue, so the cyclist can accelerate at 5. So the slope is 5. The gradient's 5, and she has a top speed of 10. So when she hits the top speed, then she's going at a constant speed of 10 now. And this is the time, and this is the velocity. Okay, continue, Jerry.
The lorry can accelerate
Yeah.
at only half the rate of the cyclist, but it only limited by static speed limit, which we will assume is speed.
Okay.
Excuse me, scared.
Thank you, KJ. Thank you. So these are my two graphs, and my question is probably, when do they meet?
Yeah.
So how long until they meet, and how far? Okay. So what's happening here is the cyclist and the lorry are stopped at traffic lights. The cyclist will move away faster than the lorry. However, the cyclist has a top speed, a limit. The lorry does not. So although the cyclist gets a head start, the lorry will catch up. Yeah, to catch up, continue. So we want to know, when will that happen? So let's say that happens at time t. We know that both have travelled the same distance. If you think about it, they both start at the same place, and they both finish together at the same place. So if they both travel the same distance, it means this area and this area is the same. Yeah. So we know that the slope is the y over the x, the rise over the run, the y2 minus y1 over the x2 minus x1. So if this slope is 5 and this side is 10, then this side would have to be 2. Because remember, if I say the slope is 5, it means for every 1 you go up 5. So if you went up 10, you must have came out 2. Okay. So this area here is a half the base by the height. So the area here is 10 meters. 10 meters. What's this area? It'll be 10. No, not 10t.
T minus 2.
Yeah, 10 t minus 2. Yeah? So the total here is 10 plus 10 t minus 2. Now here, if this is t, then this side is 2.5 t. Because for every 1, we go up 2.5. So for t, we go up 2.5 times that. So the area here is a half t times 2.5 t. So we have 10 plus 10t minus 20 equals 1.25 t squared. 1.25 t squared minus 10t minus 10 equals 0. Yeah. Mode 54 or mode 1. Can someone give me the answer here, please? We have two answers.
X.X9
Okay.
and negative 0.89.
Negative? Well, that's definitely not an answer we can use. Yeah. Finally, the distance. Which would be the easiest picture to work out the distance? Because remember, in both cases it's the same. So we'll just use this one. So we'll have S equals 1.25 times 8.89 squared. What's that, please? Okay. Did you get a different answer, Monica?
What? Maybe 10 T plus
10 T plus
Go ahead.
10. Here?
10. Yeah. No.
Here?
Oh, yeah.
Oh! Oh, I see. This is quite bad. I should have...
Minus 10 T plus 10.
No, but if I take this here... Yeah, plus 10 here.
Yeah.
Ah, rats. Okay, so that changes these two answers then. So what do we get now?
T 6.83.
Yeah, or?
Negative answer.
Okay, great. So if we just take that in the S, what do we get?
58.3.
Okay. Is that the answer I have it back, hopefully? Yeah, okay.
In the video, it kept on saying that the lorry must have exceeded the speed limit.
Yeah, because in the original version of the question, I did have a speed limit in the city, and I thought that the lorry wasn't actually going to hit the speed limit. So I made the numbers too big. I had the lorry driving too fast. So then I just changed the question and pretended that the lorry didn't reach the city speed limit. So I don't know, it was speeding in the city or something. Maybe I'll re-record that video since it was confusing then. Okay, what's next?
Do you use that relative act for this question?
No, not really. Why can't you use UVATS?
Because this is hardware.
No, I mean, for example, here you could use UVATS, but not here.
Oh, why?
Yeah, why? Someone tell me.
What? Just because it changed
The slope.
yeah. But we can.
Yeah, if you want, you can make it 2 UVATS problems. Is that what you mean? On the left. UVATS equations only work when the slope stays the same. If it changes, then you have a problem. If you really want to use UVATS, you can use it on one part when it's this slope, and then when it changes, use it again. But I feel like this makes extra work.
Yeah.
You don't look happy, Jerry.
Not,
It's okay? All good? Okay, alright, good. You can use UVATS, but I feel like it makes the question longer to do. Which, you know, I try to do the questions the quickest way. Yeah. What else do we need to see now? Another? Equation of motion then, yeah? Okay. Number 5. Okay. Go for it, Jerry.
A ball is thrown vertically upwards with a speed of 30 meters per second.
Like this?
Yeah.
Okay.
How far has the ball traveled after 3 seconds?
So, if you did this, you might be wrong.
Which calculate that how long it be into 0.
Yeah, we should do this first.
I do this but it doesn't.
Oh, maybe my answer's wrong. Let's check. So what I'm going to do first is I'm going to work out how long until it reaches the maximum height. So that is 30, 0, minus 9.81. So let's work it out here. V equals U plus AT. So what's the T here? Yeah, what is it?
3.06.
Thank you. 3.06. 3.06. And the S is UT plus a half a T squared. So what's the S here? 45.86 then. Okay, so what happens is it takes what was my original question? How far does it travel after 3 seconds? Oh, well, that's not what I wanted. Because I wanted it to go past the maximum height. Right. What's my answer at the back?
45.87.
Usually use t equals 3 seconds.
Yeah, I should just use t as 3 seconds. Yeah. Okay, so if you change this to 3, what answer do you get?
86.
The same answer with a different number. What's my answer at the back?
89.
Okay, I'm going to change that question then. I've made a mistake in it. I wanted to make it hard, but instead I made it wrong. Yeah. Which number is that now? 5. Oh yeah, 5, but this is in the kinematic equations then. Okay, I'll change that. I'll make it hard, not wrong. Right, what's next then? Was that all the problems? Another question? Yeah? So, forget that. You know what, just forget this. Yeah. I'll,
Maybe the task is we should use that 3.0.
no, I'll change the question. I'll change it to something like, how far does it travel in 5 seconds? Because then you have to do it, how far does it travel here in 3 seconds? And then how far does it travel in 5 seconds will give you this. If you minus the answers, you get this. So the total answer will be the first distance plus the difference. Or, if you want, you could do it like this. The distance it travels to get to 3, and then you could start a new problem. How far does it fall from here for an extra 2 seconds? Because we said it was 5 seconds altogether. And then you could add the two answers together. This is what I was trying to do with this question. To get you to try that. Yeah?
So if you just wrote 5 seconds,
Yeah,
we wouldn't know that 3 was the maximum.
yeah, exactly. That was what I was trying to trick you with, which I failed because I have the wrong time in. That was exactly my point, that I wanted you to see, for these problems you might have to think about if the ball is going to go past its maximum height, and that changes greatly the distance it travels.
So we have to find like v equals to 0.
Yeah. And you see, my point was, it might not say that in the question on purpose to see if you can think that you might need to do this then. Okay, any other questions to do? No? Everything else was easy peasy? Yeah. Just before we can go on to the next lesson, just quickly enough, I just want to show you, now that we've done a few lessons, what these questions might look like in the exam. Okay, so I'll open it up here on the computer now. I have one. We haven't done this yet, or this, or this. Ah, here's an excellent one. Explain the difference between a scalar and a vector. You know this one? And this one, what is the magnitude and the direction of the resultant? Now this is one that we had kind of in a homework. What do you need to do here?
Cos 70.
Yeah, cos, 30 cos 70 and 30 sine 70. And then the 60 minus 30 cos 70 gives us the total this way. Yeah, okay, so this one's actually nice, because that's 6 marks. It's not too difficult. We haven't done this yet, or this, or this, or this, or this. But, not this one. We are going to be doing this soon. These are when things are thrown at an angle, you know, so like it launches like this. Okay, so let's just have a look. So far in this exam there was a vector question for 6 marks. So let's have a look at this final exam here. Yeah, what's the difference between a scalar and a vector? A boat sails 200 meters south, then 150 east in 80 seconds. What is the average speed of the boat, the distance travelled, and the average velocity? So we did one like this. Not that one, not that one, not that one, not that one. No, no, no. Nope, not yet. Not yet, not yet. That's another projectile question which we haven't done yet. You know these ones, Jerry? Oh. So I think what would be nice just to finish the tutorial is if we have a look at those vector questions. I think that other question is too easy to do. The one where you have to add the 2 vectors? Or do you want me to do it? Give me your... Don't be influenced by the fact that I just said it was too easy. The one I showed you a minute ago, where you had vector, vector, and you had... Okay. So, how about we'll just do this one together. So, explain the difference between a scalar and a vector. Alright, well just tell me, you don't write it down, what is the difference between a scalar and a vector for 1 mark? So what makes them different? So, yeah. And vector has direction. Good. Okay. So a boat so maybe you could just draw this and then we'll do it. A boat sails 200 meters south and then 150 meters east in 80 seconds. So I'll draw that and you draw that and we'll do it together. So it goes. Okay, let's have a look. Anyways, if you didn't draw it, I just drew it here. Okay, so the first question is, what is the average speed? So how do I get the speed here? Total distance over total time, 35 over 8. What's that, please? 4.375 meters per second. Now, I don't think he's trying to trick you, but you have to be careful with the English in part B. Let me read it to you. Determine the distance of the boat from its starting position. Yeah, I don't know if he did that on purpose, but that's actually the displacement rather than the distance. Because he didn't say determine the distance travelled. He said determine the distance from the starting point. So that means he wants you to work out this distance. So this distance, which is like a displacement, is square root 200 squared plus 150 squared. This is 3 and 4. Is that 250? 250. Okay. And lastly, what is the magnitude and direction of the velocity? Okay, so velocity. We have time. Yeah, it's displacement over time. So the displacement is 250 meters, and the angle here, can someone just hit in tan inverse 150 over 200 to get this angle, please? Okay, so the displacement is 250 meters at south, 36.87 degrees east. All over 80. So the answer is 25 over 8. What's that, please, KJ? 25 over 8. 3.15. Yeah? Is it? 125. Yes. Isn't it? 25 over 8? 3.125. This is correct, yeah. 3.125 meters per second at south 36.87 degrees east.
Sure. The sign we can write in again, like you replace with a.
This one?
And this one.
Yeah, why not?
Okay.
Because it's clear to me what you mean. You're saying it's going this speed at this direction. Yeah. Yes? Yes? So, in total, what I wrote on the board, it's 1 mark, 2 marks, 2 marks, so 5 marks then.
Oh, we should adjust the name of we can identify V equal G over T.
Oh, Jerry, I want you to practice your English a bit more, okay? It would make me happy if you used more English.
I will make you happy.
Thank you, Jerry. Thank you. Okay, so what we'll do, we'll take a break for a couple of minutes, and then we'll continue with the next lesson then, okay? And Yeah, I think this will be good. We'll do the same thing next Friday as well, and if we have time at the end extra, then we can have a look at a couple of exam questions to see what they're like then. Alright, to take a 10-minute break then, we'll start at